So we've been talking about classes, and classes are really like the most important thing there is in Java. You just have to have all the other knowledge in place to make good use of them, right? You have to know, variables and arrays and loops and stuff like that. So we could easily spend the rest of the semester on this one chapter if we so wanted to. I don't think we want to, but we could. It would be that important. But we are going to talk about them a little bit more. Certainly not going to be done just with the lecture we've already had. So when you create a local variable, which is a variable inside a method, it doesn't get a default value. This would be a syntax error, right? It is uninitialized. If you wanted to make it work, you better give it like a 0 or a 1 or something like that. So if you ever just have a variable, int x, and then later on you try to use it down here, print x, it's not going to compile. However, if it was outside of the function, if it was a member of the class instead, then it gets initialized. And all variables that are part of a class that aren't local variables get initialized to 0, or null, or false, which is the equivalent of 0. So let's go into NetBeans and make a new class so that we can start using it. And I'm going to try to be a good programmer and even put it in a separate file, though I didn't do that last time. I believe we're on lecture R. I'm going to make a new project. Take the package out. And here's how I want it to work. I want to be able to do something like this. Patient P1 equals new patient, parentheses in parentheses. And then P1 dot first name equals Joe. Right. So I know that my patient class is going to need at least one member, first name. And then we might have a last name. His last name is Bob. We might have an address, P1.address, equals 123 South Main, and so on. We might get his birth date and the weight and all sorts of stuff, but this is enough, right? Well, we need a patient class. So I'm going to go over to projects, find my lecture R, right here, lecture R, and it says default package, and you may have put it somewhere else, but right click on lecture R and do, right click on the folder above it. Oh, come back. My folder is default package because I removed the package statement. Right click on that and do new Java class. And we're going to call it patient. All right. I wonder if I can break these apart so that I'm looking at them at the same time. Looks like I can. So the class needs 3 members. It needs 3 instance members. What does instance mean? Instance means that I can make a new patient and then I can set those values, and then I can make a different patient and set those values to different things. And in patient 1 it'll be Joe Bob 123 South Main, and patient 2 would have different information, right? Carol White, 456 Mockingbird Lane, whatever. So we need these 3 variables: string fname, string lname, and string address. And I forgot that in this language, string is capitalized. It's going to make those errors go away. Right? Going to make these errors go away. Okay, finally it did. Wouldn't it be cool if we could also create patients like this? Patient P2 equals new patient, and I could say that the patient's name was Carol, end quote. Their last name is Lennon, must be related to John, end quote, comma, and then some address, 456 Mockingbird, end quote, in parentheses, semicolon. Wouldn't it be neat if we could do that? That way we wouldn't have to set all these variables separately. We could set them when we create a new patient. This relies on something called a constructor, which in Lindy's last class was the init method. While there is no init method in Java, a constructor is a method that has the same name as the class itself. Comment this out for right now. Go back to your other class. If you have more than one file open, you might, more than those two files open, you might close a whole bunch of them. All right. So I'm going to add what's known as a default constructor. A default constructor is one that doesn't take any parameters. The default constructor is what is called by here, right? There's no arguments here. So our default constructor is not going to have any parameters. So a constructor is a method with the same name as the class, with no return type. Everything else has to have a return type, and is called when the object is created, or instantiated if we want to get all fancy, is created by the new keyword. So I'm going to come up here and do that. Patient, parentheses, in parentheses. This one doesn't have a return type, so it almost looks funny. Open parentheses, and let's just print a message out. We could set default values for these guys, but let's just print a message out. System.out.println, parentheses, quote, patient constructor. Can I get rid of this? Don't know what this window is, and I wish I could get rid of it. Oh well. Like that. So now when it runs, we're going to see it print out patient constructor, because when it hits the new keyword to create the object, it uses this thing to set the values. Well, it uses the constructor, and anything you have going on in the constructor happens. So when I run it, yeah, I don't have any print statements anywhere except for print constructor, but it did call the print constructor, and each time we make a new object, we'd see that message. Well, a constructor can be made to do good work. It might set the variables to default values. Right now, they're being initialized to null, which means that they have no data. And if you try to print them out, you just see the word null. Well, let's set these. This dot fname equals default, right? This dot lname equals, quote, default, end quote. And this dot address equals default. So if we make a second patient and we don't change any of the values like we did here when we set Joe and Bob and stuff like that, if we print it out, it'll just say default, default, default. Let's add a print method to our class so that we can print the data out. It does need a return type. The return type void means it doesn't return anything. In some programming languages, you call a function that doesn't return anything a function, and if it doesn't return anything, it's called a procedure, and if it does return something, it's called a function. Well, most programming languages nowadays don't make that distinction. They just say that it's a function with a void return type, meaning it doesn't return anything, or a specified return type, like int or string or something like that. So we're going to just call this one print. inside here, let's system.out.println parentheses quote patient space plus this dot fname plus a quote space end quote plus lname plus quote space quote plus this dot address in parentheses. Now I accidentally forgot this keyword here, and I seem to be getting some system error here. I mean syntax error here as well. Oh, it's because I put a parentheses here. Don't put that there. All right, I use this reference here and here, and I forgot to do it here. You do not have to use this reference unless there's another variable with the same name that they might get confused, but I recommend that you always do. For one thing, it's nice to be able to type this dot and have it list everything, right? If I type in this dot, I can see my variables right here, and I can just hit return on one of them, and it's already filled in. Like that. But I'm not calling the print function, am I? So go back to main and call it p1.print. Right, so go back to main. And after we set all that information, call p1.print. Parentheses in parentheses semicolon. And it's going to say Joe Bob 123 South Main. Patient Joe Bob 123 South Main. Let's make another patient but not put any data in it. Patient P2 equals new patient, parentheses in parentheses semicolon, P2.print, parentheses in parentheses semicolon. Now when I run it, we're going to see it print out patient 1 and patient 2. But patient 2 has just got this nonsense information, default, default, default. But it's better than the alternative, in a way. What do I mean by that? If we did not set anything in the constructor, they would instead all be set to 0, to null. Don't do this, don't cut this, but I'm gonna. And then I'll undo it. So I'm cutting that. I'm gonna run it again. And when I look, it's going to print null, null, null. Anytime you see output of null, it's serious business. Don't ignore it. Find a way to fix it. It's even better just to initialize variables to empty strings than to leave them null. Because if you access a method of null, like if I did this, int x equals this dot fname dot length, it's going to crash because it's null. There is no length to emptiness. So when I run it, I'll watch it work anyways. Maybe I haven't run it yet. Right, it blew up. Right. So it's a good idea to initialize your data. If you initialize it in a constructor, like I had, there, or if you initialize it up here, right, to like empty quotes, or the word default, 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 it's fine either way. Just make sure they're initialized to something. All right, but I said that I really would like it if I could create it like this. Does anybody need typo correction or anything right now? Okay, here's what I want to be able to do. I want to be able to make a new patient and specify that information as I go. Well, I've already used patient P2, so I'm going to make one called P3. Patient P3 equals new patient, parentheses, first name Tony, end quote, comma, last name Stark, end quote, comma, and I don't know where he lives, so he lives on 456 Mockingbird, just like the other person. There we go. And then call p3.print. Now that's a syntax error. We don't have a function, we don't have a method, we don't have a constructor that accepts 3 parameter variables. Well, we will in a minute. We're going to go into the class and add another constructor, which is legal. We can put as many constructors as we want as long as they don't have the same parameter list. Once I create this constructor that accepts 3 strings, so it has 3 parameter variables that are strings, I can't add a second one that matches also with 3 strings. I can make one that had 2 strings or 4 strings or 3 strings and an int. I'm going to go back over here and I'm going to add a different constructor. And I'm going to put a comment that this is the default constructor. Default constructor is called by the new keyword when no arguments are passed in between the parentheses. Example, patient P equals new patient. And I guess I could hit enter and try to line all these comments up, right? And I could move this down here. Sorry for going nuts organizing my comments. Now I have skipped putting access modifiers on these things, but usually you make your constructors public. So I'm going to stick the word public in front of patient. And right now these variables are public too. And that's okay at this point. There's something very close to public anyways. There's something called package. I'm going to stick the word public in front of them too, because you will see these words and you should be using these words in every class you create. You will make your data either public or private. This doesn't have any private data yet. We might change those strings to private, but we haven't done so yet. So that's the default constructor. Now we're going to make what's known as a parameterized constructor, or I call it a custom constructor as opposed to the default constructor. This is the default because it doesn't accept anything between the parentheses. Well, the next one certainly is going to. Public space patient parentheses, and it's going to accept 3 strings. String f name, string l name, string address. No semicolon there because we're going to open our code. And inside the body of that method, we're going to say this.fname equals fname, this.lname equals lname, and this.address equals address. Like that. If I scroll back to main, those errors that were there should go away now. So what does it mean, this.fname equals name? That looks silly. Well, this specification means this variable up here. And this specification means this variable. And they have the same name, so we had to use the this reference to differentiate that from that. If we called these different things, we wouldn't have to. Like if we had a variable just called f, don't make this change, then we just could have said fname is equal to f. That's one way to avoid using the this reference. I don't have any reason for recommending you avoid using the this reference, so I'm going to undo those changes. I think it's ready to go. I need to go back over here and see why I'm getting this error message, and if I save it again, Control S to save it again, now it's gone. And when I print it, it's going to say that that patient is equal to Tony Stark. And it did. So far we have 3 different patients. Notice that it only says patient constructor twice, but we created 3 patients. If I come and look at the patient class again, maybe you can tell me why I'm only seeing that message twice. So that's where we print it out. How come we're not seeing it 3 times? When is the default constructor called? It is called when no arguments are passed in between the parentheses. So here we did it. That's when it printed it out. And here we did it. And then we made a new patient. But we have things between the parentheses, so it did not call the default constructor. It called this constructor. And this one didn't have a print message in it. We could add one. System.out.println parentheses quote. Parameterized, I like calling them custom constructor called. You never have to break your things up like I break them up. You know that I'm just doing this to make space on the screen. Or to keep them all, you know, so you don't have to scroll left and right on my screen to see them. Now when I run, I'm going to see that message appear 3 times. So when I run it and I see the results, patient constructor, we printed that one out. Patient constructor, since we didn't change any of the data, it just says default, default, default. Looks like I have a typo in one of them. And then parameterized constructor. And that's when we created Tony Stark. Right here. All right, there's more things we could do. There's a lot more things we could do to our class. One thing we might want to do is to make it so that we could do this. It is nice if we allow ourselves the ability to do this. System.out.println parentheses P1 in parentheses semicolon. And I'm going to copy that and print out P2 and P3. It sure would be nice, but right now that doesn't do anything useful. If I run it right now, the output's just going to look stupid. Patient @ whatever. Patient @ whatever. Patient @ whatever. Well, this is the name of the class, and then there's some hashed memory address or something after the @ sign. That's not any good. But if we go over here and we add a very special method to our class called toString, we can make it so that when we try to print it out by its reference, it'll actually print good data. Like this. Anybody need typing help at this point, or me to slow down? We okay? All right. So public space 2 lowercase letters, string with an uppercase S, parentheses in parentheses. And now, just to make things short, string S equals nothing. We're going to change that very soon. End quote, semicolon, return S. That's the minimum it takes, right, to get our code to compile. And I forgot something here. Anybody guess what I forgot? I need a certain word between public and toString. It needs to be a return type. What return type do I need?
String.
Yeah, because it has to match that. So this should have said public string toString. And it's giving me a little warning over here, and I'm going to ignore that. I mean, you can follow its advice and do it, and it just inserts a new little comment here. I'm not going to do that. All right, now when I run it, it's going to print nothing, nothing, nothing. Right, nothing, nothing, nothing. That's because that's what the toString method is returning. Well, toString can return something a lot better than that, right? So let's do this. Let's make it say patient space end quote semicolon, and then S plus equals this dot f name plus a space, and then s plus equals this dot l name plus a space, and then s plus equals this dot address. We don't need a space anymore. I'm just going to end it there. And now that I have that code there, toString is actually doing something useful. So when I call print ln println p1, it's just like I'm doing this. It's just like I'm calling it like that. Except Java has decided that if you call a reference like that, it calls the method's toString method automatically. So we don't have to add toString. It'd almost be clearer if we had to, but to make things look nice, they made it like that. And the reason they did it like that is so that you could do things, don't type this, like print, hello, and then plus a name, and then plus an age, and something like I said, don't type this. What is it doing? It's calling names.toString, and then it's calling age.toString, so that it can be concatenated to hello and print that message out. So that's why they made every reference type, every object have a toString, even if all it does is display the name of the class and that @ sign and some random number. Let's run it and see what it does. We see our data again, right? Joe Bob 123 South Main, and so on. Let's come over here and make this a little bit prettier, right? Quote P1 equals end quote plus, like that. And quote P2 equals end quote plus P2. And then quote P3 equals end quote plus P3. And then we see it print out, right? Patient 1 is equal to blah, blah, blah. Patient 2 is equal to blah, blah, blah. And patient 3 is equal to blah, blah, blah. Cool deal. I'm liking it. We have a way to construct it like that. We have a way to construct it with the default constructor. Now, if you don't add a default constructor, Java gives one for you. So if I do this, I'm going up above our class lecture R and made private class circle with a capital C, and then I gave it a radius, int radius, and then down here in main, why am I getting an error? So you say. All right, okay, fine. There. And then down here inside of main, I can create a circle like this. Circle C1 equals new circle. I did not have to add a custom constructor to get the circle class to work. Java gives one for you. But there's an exception. If you make a parameterized constructor, Java takes away your custom constructor. I mean your default constructor. So if I added a parameter constructor, public circle parentheses int r end parentheses this dot radius equals r semicolon. Usually I use the whole word there, right? So I should probably change that to a word radius and make this say radius. But now it's broken this one. This is the only constructor it has anymore. Java removed the default constructor, and if I want this syntax to work, yeah, it'll work if I put like a number here, right, to fill in that parameter variable. But if I wanted the old syntax to work, I've just broken my code, and anything that relied upon the way it worked before is no longer going to work. It won't even compile. So once I add a parameterized constructor, it's a good idea to go ahead and give it a default constructor as well, even if it doesn't do anything. Public circle, parentheses in parentheses, there, right? Doesn't even need to do anything. It's just a default constructor, and the only reason I added it is so that I can create a circle without specifying the custom constructor. And so this is the custom / parameterized constructor. So let's make some more comments. Not sure where to add them. Down here, maybe. A constructor is a method with no return type, and I know we've already typed this, but it's so important I'm going to make us do it again. And the same name as the class. It is called when an object is created by the new keyword. Java gives the class a default constructor, which is one with no parameters between the parentheses, but you can add your own constructors, including a default one that doesn't need to do anything, and a parameterized constructor that has parameter variables between the parentheses. Space this out a little. Add, can I type? Add a public string to string method that converts the data of the object to a string. That's a good idea. Good idea. Add that. I'm going to give some other recommendations for making classes. Prof's recommendations. Class name begins with an initial cap. So class name begins with an uppercase letter. Java follows that rule everywhere, so we may as well too. I am totally spacing out. A class should make the data private and the methods public. We didn't follow that rule yet. I did not go and make this data private. If I did, it breaks it. If I come over here and say private string fname, don't do this unless you just want to see your code no longer work. When I compile it now, this line no longer works. It can't access string fname. And I can see that in my compilation errors. It is saying fname is private inside patient. Has private access in patient. Why would you want to do that? Well, we'll talk about that. I may have mentioned it last lecture. I'm going to leave it public for now so I don't have to do that. But I'm still going to make my recommendation to make it private. And we'll talk about how to handle that. I believe we did it last time with getters and setters, but we're skipping that for now. So, name begin with an uppercase letter. It should make the data private and the methods public. And add constructors if it makes the class easier to use. What do I mean by that? Well, it was nice to be able to say patient is equal to new patient, Bob, comma, Roberts, comma, 1, 2, 3, 4 in parentheses, rather than have to call, patient dot fname and patient dot lname and patient dot address. We were able to do it in one line rather than 4. So you add constructors if it makes the class easier to use. Add toString to make the class easier to display its data. usually for debugging purposes. But it's always nice to be able to print the object and see what it is, right? See what data it's got. So these are my recommendations. And the next time I say them, they may be in a slightly different order. I might leave off that one. The last recommendation would be only one class per file, but I break that one all the time when I'm typing in code here, like I added the circle class to this one, so I'm not going to put that. Well, let's define a class one more time. A class is the blueprint for an object that is a collection of data variables and methods that use that data. Now that really should be cut and moved to the very top of our notes. So our patient class has 3 data variables. We should call them instance variables and methods that use that data. The print method uses it and toString uses it. And one of our constructors uses it. Actually, both of them do, because one of them set them to default values. So, if you add constructors, if it makes a class easier to use, we could add a little subclause in parentheses that said if you add a parameterized constructor, you'd better add the default constructor or else all your old code will break. I'm just going to leave that for you to remember, though. Is anybody's code not compiling at the moment? You need me to scroll to something. Well, we'll have to try harder to break it. What was my homework over classes that I assigned last time? Has anybody looked at it yet?
I have not.
It was the UML, I think.
So I gave you a UML and you needed to turn it into a class.
Yeah, I think
Okay.
that was the last one.
And what UML, what kind of object was it?
It was a rectangle.
Rectangle? Okay, cool. I done good. So I don't need to give that demonstration now, or if I did, it would be the answer to the homework. We did a circle last time, I bet, or maybe we made it a sphere. I think I'll leave that alone and go ahead and go back to the PowerPoint. I mean, we should add a get area, right? Anytime you write a circle class, you have to add a get area. It's just obligatory. For one thing, these things should be double rather than ints. So I'm going to change that to a double, that to a double. That's good enough for now. Now I'm going to write something that gets the area. Public space, double space, get area, parentheses in parentheses, and the area of a circle is pi r squared. So return math.pi times r squared. So math.pow radius to the power of 2. Radius comma 2 in parentheses semicolon. And the circumference is 2 pi r. So public double get circumf parentheses in parentheses return 2 times math.pi times this.radius semicolon. And for some reason I didn't use the this keyword there, but to be consistent with my other coding habits I should have. So I'm gonna this.radius. Now, I'm real sure that we either did this example or a sphere last lecture. Who remembers which one we did? Was it a circle or a sphere? All right, so yeah, so we've done it again. The only thing we might add that we didn't have last time is a toString method. Let's make the data private. According to my recommendations, I've said to do that, so I just did it. That means that the calling code cannot get the radius of it. We would need to add getters and setters for it. I'm going to leave that concept alone. for now. But we better add a toString method. Well, we don't have to, but I'd like to. So public space string with a capital S space to capital S string parentheses in parentheses, and then return quote circle with radius space end quote plus this dot radius semicolon. That's enough. Or we could make that string and then return it in 2 lines, which is actually my preference. So instead of return that, we could say string s equals and then return s. Since our data is private and there's no way to change it, I'm going to comment out the default constructor. Because if we use the default constructor, it's just going to leave it at 0 and it's a useless circle. So I'm going to come in and comment that out, meaning that I'm not going to be able to create a circle with the new keyword and nothing between the parentheses. So down here where I had a circle created like that, doesn't work. I have to specify the size. Now I have to call the parameterized constructor, the custom constructor. And then I could print it. System.out.println parentheses C1 in parentheses. System.out.println has an area of end quote plus C1 dot get area in parentheses. System.out.println and a circumference of space end quote plus C1 dot get circumference. All right, now it ought to work. Ought to print out useful information and call the get area and the get circumference. And so here's our circle. The circle with a radius of 10 has an area of that and a circumference of that. And yeah, we could create more circles if we wanted to, but that's good enough to prove the point. We could take it further. More of my recommendations is that we add a dot equals method so we can compare 2 circles to see if they have the same radius. So if C1 dot equals parentheses C2, then print they are the same. We're not going to do that this time. Does anybody need typing time or me to scroll up or down? All right, so here's our circle class one more time. See if I can get rid of this patient class altogether. Right, so that I can put more of this on the screen at the same time. Here's our circle class. Class circle. I think we're all here, so I don't need to be taking as much care, but anyways, you might come back and want to look at it again. There's the rest of the code for it. Any questions so far over classes?
Can you scroll down a little bit?
To where we're using them?
Yeah.
There we go.
Alright, thanks. I got it.
You got it too? Okay. So local variables don't get a default value. They are uninitialized. You can't use them. Class variables like .x, .y, and .z or what? No, they were called fname and lname, right, or .radius. They all get initialized to 0 unless you provide a different value. So it's actually okay to use them, although you saw that it crashed when I did a string that was left to null. Local variables persist only for the duration of the braces in which they are defined in. So if you have a for loop and then there's a variable inside it, the variable's gone by the time it hits the closing brace. Same thing for methods. this variable here, string s, is gone by the time it hits that closing brace. Since we return it, we get to use its value, but the variable itself is gone. So what does a return statement do? It passes back to the calling code a value that was calculated by that method. So getAge would return this .age. This is implying that the age variable was set to private, and we had to have some way of getting it out. That's called an accessor. Let's go ahead and add that to our notes. It's worth hammering in. Private variables usually need, or often need, getters and setters, which are officially known as accessors and mutators. That's the book definition of it. Getters and setters is just colloquial. If the client code, the book calls it driver code, so if the client driver code needs to access them. The word often in that case is not quite true. You would have to have getters if you wanted to access that value, or you would have to have a setter if you wanted to change it. So getters will return the value, will return this dot variable, and setters will set this dot variable. For example, if we have a variable called radius, the setter would look like this: void set radius, parentheses, double radius, in parentheses, and we would say this dot radius equals radius, semicolon, into parentheses. And the getter would look like this. Now it can't be a void because it actually has to return a value. So double get radius, but it doesn't need any parameters because we're not setting anything, we're getting something. Return this dot radius. That is a way that you can make NetBeans provide those for you automatically. And it's kind of cheating, but it's also useful. If I go back to my patient class, I could highlight those three variables and choose Refactor and Capsulate, and it would add all the getters and setters for those three variables. I'm going to demonstrate that and then come back to the notes. So forgive me for tabbing away from them. I'm going to go to my patient class. I'm going to highlight these three variables. You don't have to do this. I might undo it. And I'm going to choose Refactor, Encapsulate, and I'm going to add all the getters and all the setters. Click Refactor. And now, it likes to add them above my variables. I hate that. Usually I would cut them and paste them in at the bottom. But there they are, right? Set fname, get lname, and set lname, and get address, and set address. And they look a lot like the one that I just gave you, right? The setter is declared as void. It accepts a parameter, and it sets this dot variable equal to the parameter that was passed in. I am going to undo that. But it's that easy to add getters and setters, so there's no real reason not to. On the other hand, some people think say that they clutter up the code. When I did that, it changed these to private, which is appropriate, because if you have getters and setters for it, they no longer need to be public. Oh, do I need to go back to the notes where people... Let's go back to the notes. Alrighty. Anybody need that, or are we all good there? Okay, cool. The void return type means it doesn't return anything. That's like when you were writing a Python function and it just didn't have a return statement at the bottom. Well, in that case, it really did return something. In Python, if you don't have a return statement, there's a secret hidden return statement that returns the word none. In Java, it really doesn't return anything. So every method you write is going to have a return type, whether it's a variable type here, int, float, string, long, whatever, or void. The exception being the methods. Methods don't have a return type. Constructors. Constructors don't have a return type because they're just creating that object. So an empty return statement is what you need if it's declared as type void. But you don't necessarily have to have it. You can leave it off if it's not returning anything. But if you declare it to return a value, like our circle class has something called getArea, it has to return a double or something that can be converted to a double. If we just had a return statement like that, it's a syntax error because it has to return something that matches that. But if it's void, it doesn't have to. I don't have any void methods in this one. Maybe I did in the other one. Let's go look in patient. The print method was void, right? So it did not have to return anything. And if you tried to return something, that's going to be a syntax error because what it is returning does not match its defined return type. Software engineering problem. Well, that's a big observation. That's a big block of text. Real-world programmers are often asked to maintain, to fix and improve other people's code. Quite often that's one of your first programming jobs, is to do maintenance on other people's projects. In doing that, they often find themselves having to examine all the loops and even more specifically the loop termination conditions. It's important that loop termination conditions are clear. Normally, loop termination conditions appear in the standard places, in the heading, and the for loops condition, but you can stick a return statement in the middle of it, and that makes it harder to read. So if we did this, I don't know why we would, but in our circle class, if we had something that was going to print something 10 times in a row, public void, print something, and it had a for loop, right? Don't type this. This is all stupid. Int I is equal to 0, I is less than 100, I plus plus, and it prints something. And then down here at the bottom we have a return. You know, maybe it's not defined as void. Maybe it's defined as int, and so it's going to return 100 there. And a programmer coming along would notice, oh, it's supposed to return something. Oh, I see what it returns. It's all good. They might not realize that in the hundreds of lines of code in this for loop, there's also a return statement hidden in here, right? Some kind of if statement. So if x is equal to 50, then return 30, right? Sorry, not x, I. And I badly formatted all this, and I'm going to delete it anyways. But the point is that if you have a return inside the loop, and you have a lot of code before and after it, it may be really hard to spot it. So the maintenance programmer might have a hard time spotting it. But on the other hand, sometimes it's really convenient to be able to return out of it. What might be a better solution is to break out of the loop and then return at the bottom. People usually like to see return statements either up at the top to rule out error conditions or at the bottom. And if you stick them inside loops like that, then it's harder to follow. But if you need to, you need to. If it makes the code easier to read, go ahead and add a return in the loop. If it makes it harder to read, then think about that. Almost getting done here. Whoops. In the interest of maintainability, you should use restraint when considering the use of return inside a loop. If inserting the return statement makes it clearer, improves its clarity, go for it. But if you did it just because it made the coding easier, but it makes it harder to look at, to understand, then don't do it. So Java, this will be the last thing we cover today. Java uses pass by value or pass by copy when it's filling in the parameter variables, meaning that it provides a copy of the argument's value. What do I mean by that? Go to main here and add a method, public static void test parentheses, and it's going to accept a variable called x, int x. And inside the body, we're going to set x equal to 100. Now down here, we're going to create a variable, int x. We're going to set it equal to 3, and then we're going to call test, passing x in, and then we're going to print x out. System.out.println parentheses x equals, end quote, plus x, right? What is it going to print? Is it going to print 3 or is it going to print 100? Why might it print 100, which it's not going to do? Well, x is 3, right? But we call this function, x turns into 100, right? And so when it prints it out, it's going to print 100. It doesn't. It does pass by value, which is pass by copy. It's like I give you a photocopy of a dollar bill. I still have my original dollar bill. So if you tear up your photocopy of it, I still have my original. I still have my original data here. When we call a method, the data that is contained within that variable gets copied into that variable. That's why they don't have to have the same name, right? I could call this one y, and the code works just as well, because this variable is not the same thing as this one. It's just a copy. This is a copy of that. And so even if you change it, this one still has its original data. Now it can get kind of subtle when you're talking about objects. If you pass in an object, you can change the member variables of that object. You just can't change the object reference itself. That's kind of subtle, and we'll talk about it more another time. For now, let's add one more comment to the bottom of our code. Java is a pass by value, also known as pass by copy, language, meaning that a parameter variable receives a copy of the argument passed to it. Doesn't matter whether that argument is a variable or a constant or, you know, a function call or whatever. It receives a copy of the argument passed in. So any changes made to that parameter do not modify the value that was passed in. Hope that's clear. We'll hit it again when we're talking about passing an object in. If you wanted that code to actually be able to change the value of the variable, it doesn't right now. There's two ways you could do it. One probably much more preferred than the other. One is you could make x a member of the class rather than a parameter at all. Or the other is you could return the new value. I'm going to demonstrate that and then we're done. So I'm coming up here, back to my test function. Where'd that go? Right there. In my test function, I'm then going to return x. What do I need to do? It's now complaining that that's a syntax error. Since I'm returning a value, what do I need to change? Well, let's go look, see the error. Incompatible types, unexpected return value. Well, why is it unexpected? What is x? X is an int. What does it think we are returning? What is its return type defined as? Void, right. It's defined as void, meaning it returns nothing. But now it's returning something. If x is an int, then we want to make it return an int. Then down here, I could say y equals test y. And after that's done, it will print 100 rather than printing 3 as it was before. I may undo those changes to leave the, I don't know, to leave the example as it was. Or maybe you can just remember. Yeah, I'll undo those changes. Changing x here does not change the value of y down below. X is a copy of the value of y. X is not the y variable itself. That's called pass by reference. Python does not support pass by reference. Java does not support pass by reference. However, C++ and C# do. If you want to change a variable that you pass in and have it actually take effect down here, then you would declare this parameter to be a reference. And then it would do a pass by reference rather than pass by copy. And that's like if I hand you my original dollar bill, you can feel free to tear it up and then I don't have my dollar anymore. When we do it like this, we're just passing an address in. No, we're not. Forget that. Forget what I just said about address. Passing by reference is the same thing as passing by address. So, if I told you to do something and I gave you the address of my house, you could go and modify my house, right? And my house has actually been modified. But if I didn't give you the address and all you had was a copy of my house, you could do whatever you wanted to it and I would still have my original. That's about enough. Let's stop.